Yes, sir, we are live now.
Okay, so then please start. Sumit.
Okay, thanks. It's the last session. So before going to the last sessions, I'd like to briefly introduce the 2 days seminar, 1.5 day seminar. That is a current trend in the cyber physical systems. So in this seminar, we have several tracks, is specifically the 7 tracks. One is the multimodal paradigm for CPS, of software engineering for CPS, machine learning for CPS, bio CPS, education for CPS, startup for CPS, and the student track. So in every track, there is some keynote speaker. For the MPM for CPS, the keynote speakers was Professor Hans, AC for CPS, Dr. Santonu, ML for CPS, Professor Vinayak, Bio CPS, Professor Shunil Bhatt gives lectures, and education, so CPS, the one keynote speaker was the Sharup Joshi. And for the startup for CPS, only the one speaker was there, Dr. Susmita Ghosh. And the 2 students are joining in the students track. One is the Rakshit Mittal, who is also the technical organizer for this webinar, and Rochishnu Banerjee. So we have a 7 invited talks, so 1 dialogue session, so 2 panel discussion we have already done today in the first half, and one that will be done after this short presentation. We have 8 international speakers and 9 Indian speakers from BITS and industry, and we have 4 panelists. So the yesterday we got this participation result. That is a 126 participants, and the majority of this portions of the students, 53.53%, 21.5% of the academicians from the different universities or college, and 9.3 are others who do not know whether in which category they are belonging, and the rest is a very small portions are from the researchers and the industry professionals. So we have to involve more industry partner whenever we conduct this type of the webinar in future. So we've make this event using the YouTube live lectures, and the question and answer sessions will be carried out by the Slack. And the gather is very small time, but we place gather as basically as a trial basis. So the future goals. So basically, this seminar is conducted with the both partner, that is BITS Pilani and the Telecom Paris. So the future goal is obviously strong research collaborations with the Telecom Paris, and we will sign the MOU very soon. So as this is already and the vice chancellors of the universities already saying that. We will encourage the student exchange program, both first degree, that is the undergrads, and the postgrads, also the PhD exchange program. Semester abroad programs, if possible, we will try and organize more interactive workshops on CPS, modeling paradigms of the bio CPS, etc. So thank you. Thanks for the attending. So now I just uh, uh, transfer the mic to Dominique, who is the next session chair in the panel discussion. Thank you.
Okay, thank you very much for this presentation. So there was quite a lot of people who attended the seminar, it looks like. So we are now going to have our panel discussion about CPS challenges in CPS development, considering artificial intelligence, ethics, the different kinds of applications, application domains we can have. So we have 5 panelists. 1, 2, 3, 4. No, 1, 2, 4 or 5.
I think 5
we have 5 panelists, and so I don't know all of them. So I would like each of you to maybe to introduce yourself, your name and your university, and your interest in research regarding CPS. So maybe let's be French and start with the ladies. So maybe Reena, you can start.
I am Reena. I am an associate professor in the Department of Humanities and Social Sciences, Pilani, Goa campus. And my area is philosophy, and I teach professional ethics and logic.
Oh, very interesting. For once, we have more than computer scientists. Huh? Also, maybe Susmita, you can introduce yourself, please.
I am Dr. Susmita Ghosh. I am a part-time academician. I am a consultant in the incubator here, the Big Pioneers Incubator. And actually, I'm a technopreneur. I am co-founder and director of Diagnosite Innovative Healthcare, which is a small startup focused on development of affordable diagnostics for the market.
Okay, thank you. And then we can go maybe to Santonu.
Hello, I just gave a talk half an hour back. So I am right now with ABB Corporate Research, with a senior principal scientist. And also I was with Pilani, Goa campus as a professor. Now I'm an adjunct faculty there. My interests are in cloud and cyber physical systems. Also, I did some past work on HPC and not getting much of a traction right now in that. So I have a 1 PhD student. Other than that, my main focus is mostly on cloud-based systems.
Thank you. And then we go to Hans.
Hello, I'm Hans Vangheluwe. I'm a professor at the University of Antwerp. Some of you may know me as a professor at McGill University. Well, Antwerp is in Belgium, a harbor city in Belgium. Before that, I was at McGill University. And I'm originally, like Dominique, I'm a physicist by training, turned computer scientist, but I also worked on biology. I worked in robotics. I worked in many different disciplines, which is fun. And modeling and simulation is basically the thread through all of this. As a modeling and simulationist, we can really help people in many different disciplines. And of course, it allows me to work with very smart people and learn about all these domains. Well, this has led to multi-paradigm modeling as my specialty. And cyber physical systems integrate many different aspects of complex systems, and that's why I work on multi-paradigm modeling for cyber physical systems.
Thank you, Hans. And our last panelist is Samit, who was also kind enough to help us organizing this seminar. Thank you very much. Could you introduce yourself?
Yes, I am Professor Samit Chattopadhyay. I am in the field of biology for last 20 years or more, even more. Before that, I was in USA. I was at MIT Boston, and I could see not many things related to neuronal signals and things. From that onward, I thought I would try to understand the real bio-CPS within the genome, how 20,000 genes are being regulated, and at what condition, which switch is on and which switch is off. Apart from that, I don't have much knowledge in the CPS per se, but it is Soumyadip who kind of told us, and I'm trying to think what best we can do at Pilani taking the platform. So it is a good possibility and rare chance for me to come into such kind of forum, and I wish not only here but in future we can do lot many things related to healthcare and bioengineering. And I really like Hans, who actually said a little bit which might overlap with my knowledge and experience. So definitely it would be a great idea to go ahead and do something which can overlap between all of us.
Yeah, well, thank you all for these presentations. So, challenges in CPS development. Myself, I'm a bit curious to know more about what are the challenges in ethics of CPS development. So maybe Reena, you can give your point, your ideas on that,
Okay.
if you like.
So, what I have understood is that ethical issues arise from the beginning itself. Like in each stage of cyber physical system, you can find ethical issues. For example, when you design something, or when you develop something, and when you manufacture it, or when the user uses. So in all these areas, like especially main issues like accountability and responsible, like who is responsible, whether the person who has designed it, or the person who developed it, or the regulatory body who gives the certification that it is ready to use, or the a person who misuse it in some way. So there is a serious issue of responsibility and accountability. And also I think that issues of privacy, fairness, then issues related to human machine interactions, and it's like oceans. You can see there are a lot of ethical issues, but the major issue is that it's very important to identify the ethical aspect in an issue. When we see the lot of problems, it's not very often that people can identify the ethical aspect in it, and they try to solve it, but the solution never it never becomes complete, because it's half, because the real issue is not identified. So uh, what I found, like when I teach ethics to the engineering and science students, this is one of the issues I have found out, that they don't have any skill in identifying ethical issues. And another thing is that we don't have any ethical training or training in ethics in the school level. With some schools, they have moral education, but not as like ethics, how to identify, because we just say do's and don'ts. We don't say how to take a better moral decision. That we don't give much importance to the process itself. So that is now I am doing that research, how to find out some strategies to improve that moral decision making process. Because when these students come, these are undergraduates, means they are adults actually, so they have already developed that moral standards. So we cannot change, okay, this is the thing you should not do, or that's not possible. The only thing is that we can train them to identify what are the flaws or what are the weaknesses in their decision. So that is the main challenge that I found as a faculty, that it's not very easy, because I don't know much about this cyber physical system, as I told you that I'm a philosophy person. But what I think that uh, they need some training, that a computer scientist or engineer, they need training. And the training should start from the beginning itself, because we are offering this course as only as an elective. So
So you
maximum we
mean
will get,
You mean from the beginning, right at the beginning of the training, but also should ethics question be considered even right at the beginning of projects of development of
yes.
systems
So
projects?
each stage you need some a person who is trained in ethical skill or ethics to identify, okay, when you do this may come out. So this may lead to these ethical issues. Because see, the major problem is that it may result in disastrous consequences. It's like sometimes we can simply ignore, but if you see AI in health sectors, or in entertainment sectors, any sectors, it has certain effect, or it has certain implications on n number of people. Because if you for example, simple example, that Boeing 737 Max series accidents. So if you say what was the reason, there are different reasons, but basic reason is human error. It was a human error. So, like each stage, whether is it MCS system failure, or it's a lack of coordination between the pilot and the machine. So there is an issue like human machine interaction, how you coordinate it. So these all lead to the ethical issues.
Hmm.
So,
yeah, for sure. Anyone wants to comment on this? This maybe Samit about the biological side, or because CPS used for biology may have some ethics impacts as well.
Yeah, sure. The major thing in the biology definitely is the first thing that comes is the ethics. Because many a times, even getting data, like my daughter is a doctor and she was telling you cannot just publish anything that is coming in your mind. She is handling COVID patients, but not necessarily she has any right to say anything or write anything. So ethics definitely is coming, especially in the healthcare where we are dealing with personal information. It can be genomics, it can be bioinformatics, whatever. But ultimately, definitely there is a huge role of ethics and safety also, biosafety and bioethics. So these two are definitely very important. So all of us should think in this way, as Reena said that. So I really feel that that is also a very important point that she makes.
Good. Others, any comment on this?
I have something to say. What Veena also mentioned, this machine-human interaction, and also what Professor Chattopadhyay mentioned, that ethics in keeping data and all those things. Not only that, as a startup person, I have seen all the time startup and entrepreneurship is being projected as like everyone has to be an unicorn, everyone has to be an like billion-dollar success. And if you think rationally, how many real dollar companies be formed in such a short period? So, but the characteristic is always there. It's like an impossible thing. Prediction is in front of them, so they will have a tendency to do a lot of unethical happens also.
Sorry, for me, your voice is breaking. Is it only me or it's others too?
it's breaking.
Yeah, it's breaking. I don't know if there's a problem with your microphone or something. It's hard to hear you, to understand you, actually.
Just a second. Let me. Just a second. Is it better now?
Looks like, yeah.
Is it better?
Yeah. Hello? No, we don't hear you.
Hello?
Hello. Okay, good, you're back. You can go on.
So what I was telling, that ethics is a big issue, big point in startup field as well, because all the time when people are pushed or people are shown the characteristic of entrepreneurship, everyone is told that you can be an unicorn, you can have a billion-dollar company, but how easy it is to make a billion-dollar company. It involves a lot of struggle, but many people, they do not understand. They think that this is the success, that you have to have profit, you have to raise your company valuation and all those things. So there will be, and there are tendencies to do a lot of unethical things. And some people do finally are caught in come in police's net. Some people escape and they keep on doing the same unethical things and unreasonable expectations. So that has to be taken care of. And CPS is one of the places where hacking and all those things are pretty much common. Okay, so most hackings are not ethical. We have to remember that to what data we are getting, and also like human machine interaction. Whether we are thinking that we are making error proof, we are making idiot proof, we are making hack proof, but still people who are good in that, they will find out a way how to hack it out and do like distort the system.
Mm-hmm.
So
they...
if values and ethics are not inculcated properly, it's not through a course, but there should be a social change, and there should be with people should stop showing unrealistic expectations. Then only we can have a much better CPS, bio CPS, or whatever CPS. Any system can be much better, and actually the world will be a much better place.
Okay, thank you. And what about you, Hans? Do you think multi-paradigm modeling can help in ethics?
It's a bit of a leap, and but I have an answer. Maybe, Rakshit, if I may share my screen, I would like to show something. Is that possible? I think you have to give me.
Yes, sir.
You have to give me permission. Eh?
Yes.
Yeah. Okay, that works. So, can you see my screen?
Yeah.
Yeah. So what you see is a poster for 2001: A Space Odyssey, which is a movie by Stanley Kubrick from the 70s, I guess. And what you see there is, some of you may have seen this this movie. There's in prehistory, there are some apes fighting for a well, if I'm not mistaken. And at some point, thanks to the presence of some dark monolith, one of these apes has this brilliant thought, namely to take a bone and to use it as an extension of its arm. And with that, of course, they become stronger. Right? So it's an extension of the arm. Like the hammer is an extension of the arm. And of course, the beauty, the symbolism of Kubrick is, of course, that at some point that bone gets thrown in the air, it rotates, and it becomes a spaceship. Of course, the spaceship is itself also, again, an extension of our arm. So our extensions of our arm, and of course, it's based on a computer, HAL, which is, again, an extension of our brain. So we've come a long way. Of course, whether or not this is how it happened is another question. But there is the fact that we build more and more powerful extensions of our arms, of our brain, and so forth. And which also means that the impact of decisions become larger and larger. And of course, if we go to, and now that I anyhow have my screen shown, let me repeat what I said in my talk about a running definition of cyber-physical systems. They emerge from the networking of multi-physical, mechanical, electrical, hydraulic, biochemical, and computational control, signal processing, logical inferencing, planning processes, often interacting with a highly uncertain environment, including human actors in a socio-economic context. Well, that's just saying we've gone from that bone to the spaceship to very complex interacting systems. And the impact of a small decision is becoming harder and harder to predict. And of course, it means that reasoning about what is ethical and what is not upfront becomes more and more important. And now you might say, what is the link with modeling? Well, maybe we can try to model these complex interactions, and we can try to somehow do a full system analysis of all these emergent properties and so forth of the system. And that may help us to make more ethical decisions. Ultimately, it comes down to the human, of course, who has to set boundaries, but the ability to do this what-if analysis, and I would like to make the link with the talk about the digital twin. maybe these complex cyber physical systems will have digital twins, which can actually be used not only to monitor, to do diagnosis of faults and detection of faults and diagnosis, but maybe also to answer questions of what would happen if we made this decision now. And so maybe in the future, we as humans too will have digital twins, and they will help us make the right ethical decisions. Okay, I'll stop sharing. So that's my link between modeling and ethics, Dominique. And CPS.
Very interesting. Thank you. Santonu, you want to say something? You're muted.
Hello. Hello, can you hear me?
Yeah.
Yeah, okay, good. Well, I mean, I actually would love to have panel discussion on 2001 Space Odyssey because that's one of my most favorite film. And in fact, you brought about the ethics. Actually, there are very nice ethics things there in that film, specifically that killing that supercomputer, and even if you're watching Black Mirror, then surely there are quite a few ethics question of AI. Yeah. So, but again, I mean, I would love to have that kind of discussion. You guys should actually arrange that someday. Coming back to this topic, well, I would not really agree with one of the points that my previous speakers talked about, specifically where they're saying that people should be basically be aware of they should have some expectations and so on. In essentially, they're saying that people should behave more rationally, so that and only then things can be achieved. I mean, I disagree because people are not going to do that. And it is not good. I mean, in my opinion, it's not a right assumption to make at all. In fact, on the contrary, you should assume that that's not going to happen, and then ensure how certain things can take place. Now, in terms of, at least in the case of cyber physical systems, and when you're building really complex systems, you know that these are all, if you take smart city, for example, or smart building, for example, where every single thing is monitored and measured and data is collected. So obviously that means that requires a lot of personalized data that is also getting collected. In the case of industrial automation for kind of machines where you are collecting data, well, there are some ethics, but those are all more of business ethics. For example, certain type of events or data that you cannot really, give it to, some other place. It should be within a boundary, and certain type of data should not really go out of the premise. That's more of a security issue. But at least these security ethics, they kind of sometimes overlap. So, but in other contexts, which are not really industrial automation, when you have this kind of cyber physical systems collecting a lot of personal data, of course, there is, you are going to collect data. And if you collect more precise data, you can have more accurate information. But many a times what happens is that breaches the privacy, and that there lies this issue of ethics. In fact, hacking is always unethical, in my opinion. I mean, if you do it at home, that is fine. But if you hack some other system, I mean, that is clearly unethical. There is no second doubt about it, and it is really not a very practical idea to assume that people will stop hacking. No, it's not going to do that. In fact, you have to build systems so that it can be prevented. So my point is that there are techniques that are happening today which are going to actually do some kind of a fine balance between this ethics and ethical data collection. Like when you are collecting data of a person, you might always fudge it and then publish not the exact data but more of a approximate data. Or when you are collecting a person's movement, you should not really make the data public. And there are laws today which are there to kind of ensure that such data are not really kind of becoming public without the person's knowledge. So these are there, and of course there are, I mean, the laws are there, but techniques are not there to ensure all the time. But I guess that has to be there. Otherwise, it's going to be more and more collected, the connected systems, connected society, where we are going to deal with a lot of data, and of course the data analysis and making predictions, which are fine, but the moment you want to publish it, these ethics issues, not the ethics, possibly other privacy issues would be much more important, I would say. I mean, I don't know if that's called ethical or unethical, but it's more technically correct would be privacy issues. I think that need to be honored, you know.
Sure. And what about artificial intelligence in that? So can that really help in that matter, or can also artificial intelligence, it's going to be integrated maybe more and more into cyber physical systems? So can that help?
Yeah, I mean,
also
AI of course are there, but as long as, let's say, these are maybe AI for industrial systems is one story, but with the moment you employ AI robotics, for example, in healthcare, then it is dealing with human and patients and so on. Then these are I don't know if it is an ethics issue, but there are of course issues of maybe taken. I mean the issues of checking the person's health. But the moment it becomes if you are dealing with person's mental stress or trying to address that using AI, there might be some kind of a ethics issue. I mean, again, it's not happening in reality. I don't know much of AI, at least. I mean, whatever I see in the industry, based on that, I'm saying. But if you stretch it, then of course there will be ethics issue. For example, if you build a chat, if you build a bot or chat bot which is going to behave like a human and then give some kind of a false promise, or give certain kind of a false assurance, and maybe that is not really right, and one can really do that. I mean, what I'm trying to hint at is that if you look at all this Black Mirror kind of science fiction thing, which are reasonably not a very, I mean, which are reasonably at least not correct, but at least not too mumbo jumbo. There, of course, a lot of such issues have been addressed, or at least they have been raised specifically with respect to AI, where there are human replacements which are trying to, or social media kind of stuff. Of course, there are tons of such issues, but they're not really cyber physical. They're in that
they're wider than cyber physical system.
Yeah.
They're about technology in general, anyway.
Technology in general, but if I only focus on cyber physical systems, then and if you bring robots, for example, there, I don't know if that robot is, if you build a humanoid, for example, which is going to be a companion, maybe those issues might come. Whether you should treat the humanoid like a human or not. Even that is also a question. In fact,
Very good. Anyone else wants to add more something about this topic? No.
Maybe I can say something about. Of course, AI is a very broad area, and if you look in the 1980s, it was all rule-based systems, reasoning, and now it's very much based on deep learning and lots of data and training neural networks, for example. And the danger there lies, and this holds for cyber physical systems, whether they contain AI or not. Given the enormous complexity, maybe explainability goes away. And there I see a link with ethics, that the ability to explain why you did something and why you, but maybe it's an AI doing something, if that is gone, and we just say, well, the machine knows best because it was trained on so many, on a data set of so many terabytes, well, that is not really a proper answer. There must be something more there. There must be some chain of reasoning being able to say it was because of that. And ultimately, of course, it will come back to a human decision somewhere. And well, it was mentioned before, like self-driving cars. Is it the car manufacturer that is responsible if an accident occurs, or is it the driver who has basically no control anymore? So I think this notion of explainability, whether it is of something that was trained, like a neural network that was trained, or it is a very complex interacting system of many different components, cyber and physical and human and sociological, in both cases, this explainability becomes an issue. And at least, but I'm not a sociologist and I'm not a philosopher, but at least to me, there is a missing link there, or there is a link between ethics and complex system dynamics.
Actually, I would certainly add to your point. This is a very important part. At least in the AI, if it is black box, then there are a lot of ethics issues coming. Like, for example, I mean, I heard things like gender bias kind of decisions that are coming up, or even colors and based things that AI-based systems are actually saying, which are definitely ethics issues. And one cannot say that, oh, I don't know, it is a deep learning thing, or the data has done that. I mean, it's not my fault. That cannot be accepted as once you put it into production. And for that, explainability makes it a white box. Now, at least to an extent, if not completely white, but it's a gray box. You know exactly why it is happening, and therefore, yeah, I mean that at least. Say if you take example of this, like color bias thing that I heard was causing a lot of issues. There, even if you explain that, well, it gave a color or gender biased answer because my data was skewed. I mean, you can explain things, but that is not acceptable, I guess. I mean,
Can you give more info on this example, Santonu? What was it, the problem exactly?
Well, I don't have the exact example, but it was I think it was actually commenting that AI ML based system, because it got more data on male, not female. Therefore, it was basically saying something or commenting something which was obviously not gender neutral. It became more of male oriented.
It was a machist machine, or what?
I'm not able to recollect right now. This and the second one, of course, was color. I mean, black versus kind of Caucasian sort of issues. I mean, I don't have the example right now, but I did know that those two issues were big issues.
Dominique, I heard this point what the Santonu told just now. So I think that incident is recently occurred in some MIT or some Ivy League university where the data were there, and some word is very weird type of things, and that can become some.
Yeah, some words or objects. Yeah.
Yeah. So actually, I heard this very recently.
I see. Yeah, so we're more. Yeah.
It turns out that my colleague Ton Kalders, who's a data scientist in Antwerp, that's his specialty, this bias in machine learning. And of course his papers get cited a lot recently. So I can send you some of these papers about the introduction of bias in machine learning, because it's indeed, as was mentioned before, it's entirely based on data. And if the data or the real society is biased today, well, then probably what you learn will also be biased. And this is a big issue. And actually just being able to identify that there is a bias is an important topic nowadays in machine learning.
Yeah, definitely.
I can add that recent research shows that to solve these issues, AI scientists, they are trying to implant moral guidance in AI machines. So moral guidance, like now, if you take moral guidance, there are basic theories, that is what is the consequence of an action, and whether a person is doing. I mean, so these are the moral guidance, checking the consequence of an action, and whether a person is doing right thing, that action itself, judging the action, and maybe implanting virtues. But I don't know how much it is possible to define, like for example, honesty, how you create algorithms for defining honesty. It's not very easy. Even for human beings, it is very difficult. We take moral decisions sometimes using emotions, And see, a simple example is, suppose we don't harm any person intentionally, the other person can understand that the person didn't do it intentionally. So that intention, how that system understand whether that other things does, whether with intention or unintentionally, or it is very complicated. It's not like maths
Yeah,
solution. 3 plus 2 is
the
equal to 5.
human is a very complex system.
Yeah, Dominic, in Slack, the Kanchon Manna pointed out the same thing. That study was offered in the Princeton, and the Princeton, and it's a basically biased AI. The Princeton study indicates the race and gender bias has crept into the machine learning algorithms. So,
Yeah,
I
yeah,
see.
that is
yeah.
Very interesting. Yeah. So maybe for the we can move. We talked a lot about ethics. We can maybe talk also a bit about more the challenge of developing these CPS that are more and more complex, and that may also include AI. Or also, is AI going to help us developing these systems? Do you think a multi-paradigm modeling has a solution to everything, Hans?
You don't need to ask, no. But no, of course, multi-paradigm modeling is a way of thinking. No, it isn't really a solution. It's just saying model everything explicitly, and good things will happen. Even reason model and reason explicitly about ethics, and good things will happen.
Yeah. So, what would be the challenge in the CPS development? The future challenges, basically, is to deal with complexity, I would guess.
I think it's, well, my very, very high level talk yesterday was, of course, all about complexity. And I think this is always what we are dealing with. The ability to somehow maintain some control over the monster that we created. And it may be just a machine, it may be a robot, it may be collaborating robots, it may be robots collaborating with maybe the traffic control system, and so forth and so forth. And the system becomes more and more complex. And somehow understanding that complexity, and of course, from an engineering point of view, harnessing it when we build these systems and still guarantee certain levels of quality, resilience, and so forth. This is, we keep pushing the boundaries now in this. And of course, we as humans, we break down the problem into sub-problems. We navigate between levels of abstraction. We have different views. These are our basic ways of dealing with this. But from time to time, you see that signs, if you look, for example, at model checking, the moment that BDDs, binary decision diagrams, were invented, all of a sudden, we could analyze much larger state spaces. So from time to time, there's a breakthrough which allows us to shift the level of complexity that we can harness a bit. And I guess this keeps moving. And I think that's what it boils down to, no? Dealing with complexity and giving certain guarantees, certainty, and safety critical systems. But you could argue that maybe safety at a much higher level, at a sociological level, maybe that's where ethics comes in. That's a kind of safety, but now for society, maybe. Okay, now I am becoming philosophical. Okay.
So I guess maybe we need some paradigm shift there. So, any comment?
Yeah, I think I would agree that this multimodal paradigm is really not a solution, but that's a way to go. But from the industry point of view, I could see that at least what's now realistic is people are actually trying to build small models, small parts, and rather than the whole factory, whole plant, and trying to analyze, because it's just too complex. It's just too complex. It's even small things are being tried out. As I said, that if you want to really get if you want to really model it and be as truthful as possible or as close as possible to the physical entity, then you have to go for more of a physics-based model. But that's not always possible. I mean, you can't just have physical or algebraic equations for everything. So this fine balance of actually having discrete systems and continuous systems, combining them together, and then have more complex systems which are on which you can do on which you can do simulations. I think there are challenges. I'm not saying it is impossible, but at least in the near term, people are working on it in industry. They're just trying with one or two small cases. Like I know that they are looking at physics-based models. They're looking at more data-driven models to try out things. I have not seen people using, let's say, discrete models or automated or Patriot-based systems. That's not yet popular at all in the industry. They're more into data as well as or kind of physics for some reason. They use that kind of model. Of course, it is multi-model, but they're not using the kind of models that you and I would be interested to hear, like discrete models. Nope, it's not there.
Yeah, like even at your industry at ABB right now, they're not so much.
Not so much. Most of them basically believe that physics-based models or data-driven models, these two, AI, ML-based models, but not really the other type of model like logics and like discrete event systems, verifications. They think that these are they sound good, but whether how much practical it is, how scalable they are, to what extent it can really address the real problem. Can we trust this to deliver the solution at scale is the point. They're always worried about at scale. Small toy things, yes, it is possible, but at scale, is it possible? Big quests, big doubts, big doubts.
Mm-hmm. Yeah, so it seems to be still a problem to introduce these modeling practices and then for real in real systems. Huh?
They ought to hear a success story. I mean, Boeing or somebody or Airbus, they should come back, come forward and say that, hey, we used ADL to model complete or with this complex system, and we really have been able to solve a certain part which are not possible using physics-based model or data-driven models. That kind of story need to be told.
Yeah, so maybe to come back to your example of production systems, what we do notice, of course, is that in any domain, there's these levels of detail and level of abstraction. And probably because of the underlying laws of physics of continuity and mass conservation and so forth, there is this notion of locality, that something which happens here doesn't necessarily influence the behavior of systems on the other side of the world, unless, of course, we have telecommunication and so forth. Why am I coming to this? That if you look in production systems, at the very lowest level, it's physics, and maybe you have some gantry, and it's flexible, and you need to model using finite element models how this bends and so forth. At a higher level, this is just a component in a production system. And maybe from the point of view of supply chain, maybe I can use a discrete event model. And maybe at an even higher level, a nice example is traffic modeling, where at some level of detail you use physics-based models at the skidding of a car when it accelerates and so forth. At a higher level, you see them as independent entities. And at an even higher level, you can see them as a fluid, and there's the flow rate and the pressure forming. And so depending on the questions that you want to answer, at different levels of abstraction, you may choose a particular abstraction which somehow ignores the details, but the details don't matter. And maybe as a physicist, I have to give this example. We can study the motion of atoms in a gas, and we can study them. They have a certain velocity and so forth. And then we can take an average, an ensemble average, and we actually arrive at this macroscopic notion, PV equals nRT, the relationship between pressure, volume, and temperature. This is the ideal gas law. And this is what we use all the time. But of course, there is an assumption that was made that all the atoms are indistinguishable and that there are at least 10 to the power 23 of them. There must be lots of them. Yeah. So what happens is, under certain conditions, jumping to a completely different level of abstraction actually works. And of course, we must know the boundaries of these assumptions. And so I think there has a lot of work being done in multi-formalism modeling, but this multi-abstraction, I think we use it as humans. We use it in physics, for example, in statistical physics or statistical mechanics, but it is not in industry used that often yet, making the relationships or studying the relationship between these detailed models and these higher level models and these even higher level models. And you see, there are entire conferences about supply chain modeling, which use queuing networks, which use discrete event models, but they're sort of isolated from this lower level where you have the details, where you have the details of the physics. And so maybe that will be a trend once we start integrating them more, or we understand these relationships better. Maybe we can push the boundaries of the complexity we can handle. I don't know if you agree that there seem to be, they emerge these kind of levels of complexity.
Yeah, absolutely.
Which
Yes.
Which are somehow related.
Yes.
Mm. Yeah, so maybe you're saying basically that maybe these models are not used because people don't understand when they can apply them, right?
More than that, at least they really do not have the scenarios or use cases that if I go at a higher level of abstraction and use, let's say, rather than physics-based model, have more discrete kind of models, and then possibly, as you go higher and then make it more about abstract, you can cover a lot of your breadth increases. But they want to know that, okay, with this, what can I do? I mean, what purpose will it serve? I mean, I'm fine with my physics-based model because I know exactly how this particular motor is running, and then I want to basically analyze that, and I'm happy with it. But the use case that, okay, you have that as a tiny part, but how do you want to address few other issues for which you need to really have a continuous time model, but at the same time also combine with discrete event models. That they are not really appreciative of is what I'm saying. They are mostly focusing on, and they understand.
But do you think things are improving?
Well,
do you think things are improving, or they are stagnating?
I don't know, because at least I know that there is a heavy bias towards AI and ML. For maybe, I mean, they think that it's a kind of a magic, like silver bullet. They think that either I do go by the physics, or I collect a lot of data and then apply some ML or AI technique, and that will give me the answer. Because they're actually getting a lot of data. So that's what they are. I mean, maybe hopefully sometime in the future they might understand, as you are saying, hierarchy of model, and maybe I'm sure they will understand.
The topic of a lot of data, by the way, what you see a lot in industry, you must see this much more than me, is that there is this promise of we have a lot of data, so we will get a lot of value out of it. But of course, data should be the result of a controlled experiment, and you should do an experimental design. And what you often see is that if you actually do the analysis of the kind of information you can get out of all that data, which was not, the data was just collected without really doing an experimental design, the result is that the answer is that you can't get anything out of it. Because the data was measured at different points in time with different conditions. There were so many things that were varying. You may have terabytes of data, but actually the conclusions you can draw from them are actually nothing. And this is something which I think will require a bit more education of the general public, because, and I'm afraid that in companies, this is often, AI is sold as, well, you have lots of data, so we'll give you value. And if you look at it in detail, it means there is no value coming out unless you actually set up your experiments in such a way that the data is actually going to lead to some insights. But you probably have more experience with this than me. I've seen this a
No,
number
no,
of times.
I would agree, because what's happening is that they are getting data and they think that, oh, I have data, and then they believe that, okay, if I have a model and in which I give tons and tons of data, I'll surely get something. And of course they get something. It's not that they're not getting, but whether that is useful or not, who knows? But yeah, but overall, the whole industry is now, into this of munching data, crunching data, eating data. So,
Yeah, without knowing if it's relevant all the time. That's the problem. Yeah. That's a big. There's a big challenge in using these artificial intelligence techniques, I guess.
And of course, I didn't want to be too negative. This is how science has advanced. No, Newton saw the apple fall and saw it fall a number of times, and then somehow got some insights. I think maybe in all this data, we will actually find new constitutive relationships. We will get new insights. So don't quote me as too negative.
But on a kind of lighter note, like Newton saw that apple falling in pandemic, right? They had a pandemic in that time, so we are again having a pandemic. So I hope something bright will happen.
Yeah, very interesting. Yeah, and okay. I guess we're getting close to the end. Any concluding remarks? Maybe Rakshit, we should let talk our youngest person here. Rakshit, anything to say? AI is your future. You're going to live with it much more than us. You're muted.
Rakshit, your mic is
Rakshit.
Oh, I'm really sorry. So right now I'm more associated with discrete systems. I'm pretty new, but something which I would like to really point out, and especially something which I've been wondering about for quite some time, is it is something a little more general, and something which has often been not looked at by many people in the research industry and almost everywhere, in almost all sectors, which is once you have made your research claim, once you have carried out your research experiment and you have got some results, a major point about that research after you have conducted your experiment is properly using it and properly describing it to the masses, because a lot of times right now what we see is these research these findings, they are often sensationalized, and people often take them for something completely different, like AI. People assume because of movies and like just the term artificial intelligence itself, that renders itself, I think, pretty in a way which it not actually is. So I think especially I think we can boil it down to ethics, because I think this should be a big concern for researchers today as well. Like how exactly is their research perceived? How it is applied, and how do you boil it down to the level of the masses, such that they can understand it at least at some level?
I agree completely, and it was mentioned before. No, this drive towards unicorns. You have an idea, and then of course it's 99% marketing and 1% research.
Exactly.
And then you will become that one unicorn, make your $1 billion. Maybe in times of COVID, we are realizing that maybe maximizing profit is maybe not what should be our goal, but maybe resilience. The fact that we are robust with respect to all sorts of perturbations in our supply chain and so forth. Maybe we should change our goals a bit. And this is, at some point, it's a matter of changing the formula for which we optimize. And which in industry we know how to do. We try to optimize, but maybe you need to optimize maybe for more resilience rather than for direct profit or so. And now we're back to ethics, of course.
Yeah, optimize for human more than for money or profit. But then we need to be able to represent what is good for humans, what human wants, what they need. Right? That's
So yeah, so this point
challenge.
struck me,
Luckily,
like what Dominic said, right?
yeah.
Having a, like, we should now look at a new paradigm. So maybe trying to model these characteristics, ethics, or like, you know, certain outcomes. Like right now we are modeling some things which are like very tangible, like either that or we are modeling logic. Maybe we should go a little further ahead and try to model some other like, you know, characteristics of humans, like ethics.
Yeah. So maybe philosophers should do modeling as well, right, Reena? What do you think?
I don't know how philosophers can model, but really, ethics is part of it. We cannot simply ignore it. Ethics is there. Any model, whatever you make it, whatever you develop it, without considering ethics, we cannot.
Well, I think philosophers can model, because I read some tiny, you know, like philosophy book that I kind of I forgot the name of the philosopher, but he formally proved that a God exists.
That way we can model. That is only arguments, not like tangible object that you said tangible. It's not tangible.
I'm sure that
Yeah, like the simulation argument. You know that we live in a simulation.
Yeah, that's
Oh
true.
yeah.
I agree.
Okay, well, maybe that's a nice way to end this panel discussion. Thank you, everyone, for participating into this. We had, I think, very interesting discussion because we had heterogeneous people also. Makes it very interesting. And thank you again to these, Soumyadip, Rakshit, and Samit. You did a very good job in organizing this seminar. I was only involved much less than you guys. You did most of the big work there. So thank you very much.
I was not even a catalyst, I would say, because Soumyadip did, and Soumyadip stays very next to me. So I can't avoid him. And when he says something, I say, yes, let's go ahead. But this is really very inspiring, and having all of you with the different backgrounds.
Your effort, it's not possible, and more specifically the Rakshit. So Rakshit plays a very
Rakshit
important
is very important. So we are more thinking how, talents like and the brilliancy like Rakshit and others, how we can utilize that and we can fulfill our dreams. Whoever knows whatever, ultimately can it be used for the human beings, and that's what ultimate goal is. So it will be fantastic if we can work together in future in some directions with good thoughts, and we can meet frequently time to time with this kind of discussion. That would be fantastic.
Yeah. I'm actually very, very impressed at the way with this online thing you guys have worked and then actually created. I was very, very impressed with this whole setup, whole panel, whole set of talks and so on. It's very well organized. I mean, thanks to the team at Pilani and Telecom Paris. I'm sure Dominique's team also worked equally hard. But it's a very good thing, and way above my expectation.
So we can make it a point to have this kind of things and blend it with something else as well. So every time there could be a new theme, but subject will be a little different, but focus will be on one subject, something like that. So that will be something more creative we all think of.
So basically, we are all looking at the steering committee for CTiCPS.
Oh, you have high ambitions.
Yes,
good.
sir, certainly.
Yes,
but
the FMCAT, one of the topmost conference in the verification, which starts from the Stanford Research International. So they usually did using this manner. So their own broadcast material, they did webinar with the Ivy League universities, and then ultimately they host one conference, that is the FMCAD, and MK Srivas and P. Natarajan, these two members of the steering committee, then it's just like a very big conference nowadays.
Very good. And hopefully we will get rid of this COVID problem soon so that we can see each other in real.
Yes.
Right?
Very
I was
important.
really looking forward to visit BITS, but unfortunately I have no idea when that can happen and when you guys can start coming. Luckily, Santonu, you were able to come before the problems.
Yeah.
I would also like to tell that this bio-CPS that we received a huge grant, 125 crores from the DST. So the whole one of the purpose of this is to do something for the not only the innovation hub but also something related to the healthcare. So I would expect from all of you that be a part of this. It would be my pleasure to have all of you as a team, and we do something for us, for the humankind. And the money and the support that will be given, let us think how best judge are we, how we can utilize this in a very proper manner so that outcome will be something very good.
That's
This
a
is
very good
my
idea.
suggestion and my request to all of you.
That's a very good idea.
Yeah, very good. Okay. Well, thank you, everyone. So
Thank you.
Thank you.
Nice to
Thanks
see
to
you
all.
all.
Thank you.
Thank you.
And hope to see
looking
you in
forward to
person.
see you
In
again.
Leaders, Dominique
Yes,
said.
yes, yes. It will be nice.
Yeah.
Bye.
It will be fantastic.
Okay. Thank you. Bye-bye.
Bye-bye.
Bye.
Bye.
Okay. Take care. Bye.
Take care. Bye-bye.
Bye.
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 So for all our viewers, this is the end of CTiCPS Current Trends in Cyber Physical Systems 2020, the online seminar. You can all still watch the YouTube videos online. They are all there. They are all archived. So you can watch them, go through them at any point of time, and do write to us, talk to us, discuss. And thank you, everyone. Thank you for making it happen. Thank you so much.
Thank you. Thank you very much.
Thanks, Rakshit. And
Thank you.
all of
Bye-bye.
Thank you.
Thank you. Thank you all. Thank you.
Thank you. And
Thank you,
yeah.
Rakshit and Soumyadip.
Dominique also. Yeah.
Thank you. Thank you and take care.
Thank you. Bye-bye.
Bye-bye.